All right. We've already introduced the concept of u and du as using it to swap out for an expression for x, right? Like the other day when we were doing arctan and you were telling me it's u prime on top because u prime could represent some other expression. Okay, and so we've used the concept of letting u represent another expression in terms of x. So let's just reverse or talk about how you reverse the power rule for integration. So in general, if u is any differentiable function, then the way we would integrate u to the n, as long as we saw a du in there, would be u to the n plus 1 divided by n plus 1 plus c. Hopefully you agree with that statement, where n is not equal to negative 1. Okay, so we're going to use this with power rule. We're going to also use it with some other things as well, but power rule is especially an important one where we can reverse it. But what this just basically means is if this was u to the fifth, and in a second u is not going to be just an x, it's going to be a whole expression. So if we have an expression raised to the fifth power, as long as we see the du in there, as long as we see the derivative of the function in there, we can go backwards in the same way we did with just x. So we could make it u to the 6th divided by 6, right? Okay. So let's talk about what U substitution is, or how it works.
Plus c, right?
Plus c. Now, the tricky part is figuring out which function is u. But you're going to let a function equal u. And you want to try to pick the function where du is also in the problem. So you're kind of trying to look forward because you're trying to let u be a function where you also see its derivative somewhere in there, okay? What you're going to do is you're going to, we're going to just make sure we calculate du and solve for dx. And you'll see what I mean in a second. You're then going to integrate the function, and it's going to be in terms of u. And then you're going to substitute back in for u and du if necessary. Okay, so those steps are probably going to make a little more sense once we you know, see a couple examples. I'm going to start real basic here, guys. I'm going to start with something that technically I don't really think you even need U substitution for, but I'm going to show you it with U substitution so you can see how it works. We're going to evaluate x plus 2 parentheses to the 5th dx. Okay. So off to the side here, what I'm going to do is I am going to let u equal the function in here. And the function in here, and it's got to be a function that I'm doing something else to, okay? So what I'm going to let u equal is x plus 2. Because what am I doing to x plus 2? Raising it to a power, correct? So if I just had that x plus 2 be one thing, it would be really easy to integrate that. Then I want to make sure I see du in the problem. What's du? Well, what's the derivative of this side? Just dx. Okay. Here's where the substitution plays in. Okay. We're going to rewrite the integral, and we are going to replace x plus 2 with u. So I'm doing this in pink now. This is, instead of x plus 2 to the 5th, this is u to the 5th. And instead of dx, I can write du. And now we're going to integrate that expression, which is way easier. What's the integral of u to the 5th du? U to the 6th divided by 6 plus c. But we have to go back to the original expression. So now we basically put u in there to make the integration process easier. But then we put what u equals back in. So this would be x plus 2 parentheses to the 6th divided by 6 plus c. That's it. Now I think some of you probably could have done that without the u substitution, but I think that basic example is helpful because it illustrates what's going on. Let's pick another one that's really a power function. We're going to evaluate the integral of the square root of 4x minus 1 dx. Okay. And 4x minus 1, and the square root of 4x minus 1 is really a what power? It's really a power function, right? It's the 1/2 power. Okay, so how, maybe you're getting it. What do you think I should let u equal then?
4.
Very nice. Now this time, du is not going to equal dx, and I'm going to show you what we're going to do.
Why would it equal dx?
Well, you tell me why. What's the derivative of this side?
Oh,
4.
4.
This equals 4. We'll call it dx. Okay? We need to sub out for a dx. So we need to, I'm going to rewrite this. Let's get this alone. Isn't this mean 1/4 du equals dx? You agree with that then? Okay, so we need to, this is that part where I said solve for dx, because not only do we have to substitute out the expression, we also have to substitute out the dx. Okay? So let's rewrite now as u substitution. So this part is u to the 1/2, agreed? But instead of dx, what am I going to put? 1/4 du, which is okay. Are you all right with me putting the 1/4 out here and the du here? Are we okay so far? So now, yes.
Question. For the du part,
Mhm.
we did 4x or we did the 4 times dx just because there's a 4 in front of the x.
Correct.
So if it were like x squared.
It's going to be 2x dx. But what you can't do it unless you see another x in the problem, and you're going to see that it does show up. Hopefully in the next example. Yeah. Okay. All right. So, now let's go and we're going to do our integration. So we have a 1/4 already out here, right? Okay. Now let's do the rule. We add the 1 back on, which is 2/2, correct? So it would be. Yeah, I know. Adding 2/2 on. Yeah, so it would be 3/2. And so to correct it in front, I would need a 2/3, right? Are you with me?
Mm-hmm.
Okay. And then plus c. Okay, so let's simplify our expression then. Let's see here. This is 2/12, which reduces to 1/6. Oh, what in the world am I doing? 1/6 u to the 3/2 plus c. So now let's sub back in. And let's remember to write it. Your book will accept either, but I'm going to write it as a square root, okay? So I'm going to write this as 1/6. The half, I'm going to write as a square root. 4x minus 1 cubed, and then plus c. I'm going to box my final answers up here so we know